Hi everyone. So in this video, we will learn how to take your diversity data for experiment 1 and put it into a box plot. So far, we can walk through each of the commands that you have written prior to this. And remember, you can always follow along in your R manual. But first, we loaded libraries using the package gsheet. This will give us all of the functions we need to take your data from Google Sheets into RStudio. So what we did first was library gsheet, which loaded the gsheet package. We then assigned the variable URL to our link to our Google Sheet. So we took this link right on top here to our Google Sheet and pasted it here. And once we ran this code, we got a variable with a link to our data. Then we loaded the data from the URL into R, making it a table that's very similar to the table that you would have seen on your Google Sheet, using diversity data as the variable name, the arrow to load in the data, and a new function called gsheet2table using that URL that we made on line 9. So always before you're about to graph or anything, double check and click up here in this environment on your data to make sure it loaded correctly and it looks just like it does in the Google Sheet. So this looks exactly like your data here, so we're set to start graphing. Remember, you always want to load the long version because that is the version that R can read easily. All right, so if you guys want to follow along, starting on page 148, we are going to be plotting our data. So just like we loaded library gsheet, we are going to load a new package. So go ahead and create another comment for yourself. So load the package that allows us to plot data. In this case, we are going to be doing a box plot. And the command for that, which is right on page 148 again, is library ggplot2. So that is the package we will be using, and you can go ahead and run that code. So now all the functions we need are nice and entered. We'll create a gap in between our next line. And now we are going to use the ggplot command to actually plot our diversity data variable. So you can see in your lab manual that we're going to be using the diversity data variable, and then we're also going to be plotting by site type, and then using this column diversity as well. So to start, we are going to make another comment that is just going to say create a plot. And the first chunk of code that you are going to write is using one of our new functions that we just loaded, and it's going to be ggplot. We are then going to use this diversity data variable that we just made. So you're going to go ahead and type exactly as it's named, diversity data, and it'll pop up, so go ahead and click it if you want. You're going to do a comma and type AES and then add a new set of parentheses. This means aesthetics, so this is assigning the X and Y axis of your graph. So again, we're going to want to use our X axis as site type and our Y axis as diversity. So mind the capitalization on these X and Y axes. You want to make sure they match exactly what's in your data table. So if you did not capitalize site type or diversity, you would get an error message and R would not be able to actually find those variables. So we're going to go ahead and run this. And if all goes well, a plot should pop up on the down right-hand side. So it looks good. So you can see down here that while none of our data points are loaded in yet, all you assigned was the X and Y variables, and it looks like it assigned correctly. So we have site type down on the x-axis with our incoming and outgoing tides at our 2 locations, and our diversity index on the top. Now if you want to continue on to the next page, we're going to actually be adding our data points to this graph now. So go ahead and create another comment for yourself. Add points to the plot using geom_point. So remember to keep creating these comments for every new line of command. This will help you with the next few experiments. You can go back to your old code and just copy, paste, and change what you need to change. So what you're going to also do is I'm going to throw in another comment, separate, or actually let's say add to last command chain with a plus, and that'll make sense in a second. So our last line of code, we're just going to keep building off of this base with the X and Y distinguished. So you're going to do it again. ggplot with diversity data as our variable, with our aesthetics assigned to site type and diversity. And then what I mean by you're gonna add this next command with a plus is all you're gonna do is at the end of this chain, add a plus, and then type in that geom point command. And it'll pop up right here. So it's good practice to type it all out for the first set. So you can highlight that line and run that, and it should add your data points to your graph. So that looks good. Our next line of command will be to summarize your data and to actually overlay the box plots on these dots. So if you flip to the next page, it'll show you the command to do that. So again, add a comment, add box plots to the plot using geom box plot. So again, this is just another command that's we're going to overlay on top of the previous code to get some box plots on your graph. And again, you're just going to add this on with a plus on the end. So if you want to go ahead and just copy and paste this down below to make things go faster, feel free to type it all out if you want to. We're just going to add another plus and add geom box plot. Remember to add those open and close parentheses on the end. These are just here if you want to add specific changes to the physical box plot, but we're just going to do the simple version. So, and there you can see it added those box plots. Great. So remember to add these descriptive comments to distinguish creating the base plot, assigning X and Y axes, adding your points onto the graph, and then actually overlaying those box plots. Next, what we are going to do is add axis labels to these. So site type and diversity data aren't as descriptive as they could be. Remember, you want to be as concise as possible while also being as descriptive as possible. And you want to change what's just on your table. This is also a really important step because you're going to add your last name into your axes, which also will help your TA know that you did this work yourself. So we are going to plot just the box plots and change the x-axis label. So we'll do the x-axis to start. What it means by just plot the box plot is we actually no longer need this geom point because we have these nice box plots overlaid. So go ahead and type out the code that is shown on page 151. It's the same as line 26, you're just getting rid of that geom point. So it's ggplot diversity data with the aesthetics set to site type and diversity. We're going to get rid of geom point and just do geom box plot to make it look nice and clean. And now we are going to add a new command for that x-axis label. And this new command is going to be called scale x discrete. So we're going to add that onto the end just like we did before. So we're going to do scale x discrete. And we're going to add some specifications inside of these parentheses. So what you're going to do is name equals, and in quotes, this is where you can name your x-axis whatever you want. So in this case, it says conditions at site. And in parentheses in here, I'm going to put my last name, just so the TA knows that it's my work. So the reason, you might have seen it pop up when I was typing this command in, but the reason why we're using discrete right here instead of continuous or any other scale x variable function name is because our x-axis is discrete, meaning it's a categorical variable, it's non-continuous, it's non-numerical, so discrete is the scale we're going for. So if all goes right with this function, the site type down here on the x-axis should be changed to conditions at site with my last name in the title. So let's go ahead and highlight line 29 and run the code. And great, it changed. It also got rid of all those extra points that we didn't need. And so the only points left are just those outgroups, or the outliers. So now we're going to add on to this a little more and change the y-axis as well. So we're going to now plot just the box plots and change the x and y axis labels. With this command, we are going to be using scale y this time, because we're changing the y, and continuous, because this is a chain of numerical values. So it's not a category variable, it's numerical. So go ahead and copy and paste your line of code from the prior comment, which has our scale x discrete changed. We're going to add another plus and now use our new function scale y continuous. Now in these parentheses, we are going to do the exact same thing that we did with the x-axis. But in these quotes, we're going to change it to be specific to the y-axis. So instead of diversity, we can make it a little more specific. And as your lab manual suggests, let's put Simpson diversity index. So now this is telling your graph to replot this with the x and y variables. Oops. Whoops. The x and y variables changed. Going back. And if that is a good reminder, make sure you continue to save your code, because sometimes it backtracks a little bit. So now we have scale x and scale y named. Our code's nice and saved, so that shouldn't be a problem. And let's run this new line of code, renaming diversity on the y-axis to Simpson's diversity index. Looks good. So now this is our finalized graph for our group's data. You have all 4 locations at the 2 different tides. And we have our nice named axes titles with your last name in the x-axis, again, just to show your TA that you did this code yourself. So now what we're going to do is export the PDF. So over in this corner where you see your nice graph, you can click on export. You can save it as an image, you can save it as a PDF, or you can copy it to your clipboard. And you can actually go ahead and paste this into your Google Doc or your Microsoft Word document, wherever you're writing up your lab report. But make sure you always save it as experiment 1, boxplot 1, let's say. And that way it'll always be saved in your R folders. It'll always be in this cloud. All right, I hope that helped you load a boxplot.